Good afternoon, everyone. Okay, so we are going to go into lecture 3. Okay, so there is a typo error over there. So lecture 3, organic chemistry and hydrocarbon revision. So this one, as usual, I told you that it will serve as a review. It's going to be a review. Okay, it's not like something we are going to put it's not like something that is going to be a JC1 lesson. We are going to teach you everything and so on. So this one is going to be a review, and I will go very fast. Okay, along the way, I will also explain to you, okay, certain things. Okay, I think certain extra things that you can go and go in the resources that I have, and you can get the information in more detail over there. Okay, so I will move on. Okay, so the first part, okay, is going to be 2 chapters in 1 hour. So it will be very fast. Okay, but I will try to make it maybe a bit clearer. Okay, and then you can also follow. Yeah. Now, introduction to organic chemistry. Okay, we need to learn about certain formulas over here. Okay, the first formula is going to be empirical formula. So if you're asking what is empirical formula is going to be simplest ratio. Okay, this one you need to remember, simplest ratio. Molecular formula is going to be exact ratio. So what is simplest ratio, exact ratio? So let's say, for example, you have C6H12O6, okay, carbohydrate or glucose. Okay, this is going to be your exact ratio, which is going to be known as molecular formula. Okay, but if I divide all this, okay, with 6, I am going to have, okay, C1H2O. Okay, this is going to be the simplest ratio is 1 to 1. So that is going to be the empirical formula. So this is going to be the difference between empirical formula and molecular formula. And then we will move on, okay, to this structural formula, displayed formula, and skeletal formula. Now, displayed formula is going to be more easier. So I will explain using displayed formula. So if I have, for example, propane, okay, the displayed formula is going to be something like this. Okay, I need to show all the bonds. I need to show all the atoms that are involved over here. So this is propane. So this is structural formula. So if let's say I don't want to show propane, I suddenly want to just show propanol. Okay, how do I show them? Okay, this one maybe some of the students will make mistakes. When it comes to displayed formula, you need to show all the bond. You cannot write down OH like this. Okay, if they ask, okay, you must write down with another one more, okay, OH over there. Okay, this is displayed formula. And let's say we are going to use propanol, and I am going to write down structural formula. How do I write structural formula for that? Okay, for propanol. So this is displayed formula, DF. I just use DF. And I want to write down for structural formula. How do I write it down? So it's quite easy. Okay, you have CH3, you write down CH3. Followed by, okay, this one, CH2. And there's another CH2, and then OH, you put OH. This is how you write down your structural formula. Okay, you write down CH2, and so on. Okay, that is structural formula. And the last one is how do we write skeletal formula? Okay, skeletal formula is going to be maybe for some of you might be confusing, okay, but it's quite easy to write down skeletal formula because that's the simplest way of writing. We will not write down carbon. We will not write down hydrogen. So how do I write? Okay, the best way, okay, is to refer to your displayed formula. If you have 1, 2, 3, 3 carbon. So how I use skeletal formula? 1 dot, okay, represents 1 carbon. Another dot represents another carbon, 3 carbon. You do not need to write C. Okay, you connect all the dots. Okay, 3 carbons. And then no need to write all the hydrogen. So ignore all this hydrogen. Ignore. Okay, but you need to write the others, okay, other than, okay, hydrogen alone, carbon alone. If you have OH, okay, that carbon, okay, the third carbon is bonded to OH. So how can you write? You just put another line and put OH. Okay, so this is how you write skeletal formula. Okay, some students will ask, sir, can I just write down like this and then the OH, maybe I go down OH like this? The answer is correct. Okay, it is still correct. Okay, but try to do something like this. Okay, so it doesn't look good. Okay, if you just do like this. Okay, but I'm not going to say it's wrong. Okay, still correct. So you need to remember, no need to show hydrogen, no need to show carbon. Okay, then the rest, okay, the other functional groups you need to show. Now, since I mentioned about functional groups, okay, for introduction to organic chemistry in AS, you need to know certain functional groups, some of the common functional groups. And I've written over here, okay, what is carbon, double bond carbon? Yeah, this is going to be alkene. Now, alkene is going to be, it is also known as unsaturated, okay, unsaturated hydrocarbon. Okay, unsaturated hydrocarbon, and this one is going to be alkane. This is going to be known as saturated hydrocarbon. Okay, so when we have CX, what is CX? X can be Cl, can be Br, can be I. So this one is going to be halogenoalkane. The formula and so on, okay, it's not important, but by this time, okay, you need to know that alkene is CnH2n. This is CnH2n plus 2. Okay, you should know by now. And then this is going to be alcohol. Okay, and this is going to be CHO. Whenever anything ends with CHO, which is going to be, if I draw C double bond OH. Okay, this is CHO. It can be any R groups in front. Okay, this is known as aldehyde. If you have something like this, R, C double bond O, another R, okay, what is R? It's going to be CH3, C2H5, and so on, okay? So this is going to be known as ketone. And both of them, okay, they are related because they will come under carbonyl compound, okay, carbonyl compound. You have learned this in AS also, the reactions of carbonyl and so on. Now, this is going to be, okay, you have C double bond OOH. This is going to be carboxylic acid. This one is going to be R, C double bond O, and another R. Okay, this is going to be ester. This one, okay, is amine, and this is nitrile. Okay, as I told you, the detail about this, you no need to know so much because each of them, okay, we are going to learn individually. Like for example, alkane and alkene, we learn in hydrocarbon. CX, we learn in halogenoalkane. Alcohol, okay, then we learn carbonyl compound, carboxylic acid and ester, okay. Amine and nitrile, you will learn later in A2, okay. So you have this, okay, just common functional groups, okay. Now, let's actually look into checkpoint. Okay, draw the displayed formula of pentanol. So how do I draw the displayed formula for pentanol? Penta is 5. Okay, by this time you should know. If you are not sure, okay, please revise. Okay, penta is 5 carbon. It's pentanol. Okay, they didn't tell what number. Okay, the moment that they don't tell you what number, you take it as 1. Okay, so the OH can be at carbon number 1. Carbon number 1 can be here. Carbon number 1 can be here. Up to you. Okay, let's say I'm going to put the OH here. So the rest, okay, must be hydrogen. Okay, so you need to write down each of them. So this is going to be display formula, but you see, I made a common mistake like any other students will make. You can see, okay, the OH I have written together. It's supposed to be like this. This is going to be the displayed formula of pentanol. Now, draw the structural formula for pentanol. This one, whenever you want to draw structural formula, whenever you want to draw skeletal formula, make sure you draw displayed formula first because it's going to help you. So pentanol, so 5 carbon, aldehyde, okay, double bond OH, okay. And then this is going to be somehow, you can just assume that this is going to be display formula. And I want to write down the structural formula for this. How to write? This is CH3, CH2, CH2, CH2. Don't go and put COH over here, okay? This is going to be CHO, aldehyde, okay? So you need to write it down this way. Now that is structural formula for pentanal. Now next is going to be draw the skeletal formula for pentanoic acid. So I told you, if you want to draw skeletal formula or structural formula, make sure that, okay, hold on, yeah, Kate, wait, okay, so draw the skeletal formula for pentanoic acid. Okay, so I draw first, okay, the pentanoic acid, okay, you have 5, okay, and then now I want to draw skeletal formula, okay, you have all this 5 carbon. So I told you, you put 1 dot, 2 dot, 3, 4, 5, 1, 2, 3, 4, 5, 5 carbon. Carbon number 1, carbon number 2, 3, 4, 5. Okay, that last carbon has double bond O, and it also have OH. So the OH, you can put it like this. Okay, so Kate, just now I have one student asking me, sir, can you go to last slide for 1 second? Yeah, can. Okay, all this, okay, don't worry guys, okay, if you are taking down notes and so on, video will be recorded and I will pass this written document to you, okay, so don't worry about it, yeah. So we need to move on, okay. So here, okay, sigma and pi bond, okay, sigma and pi bond. We need to learn about this sp3 hybridization and sp2 hybridization. In our syllabus, they want to focus on carbon, okay? So I'll just explain a little bit about carbon, okay? When you look at carbon, okay, carbon is going to be 6, okay? So if I write down the electronic configuration, 1s2, 2s2, 2p2, okay? And if I just want to focus at 2s2, okay, and then 2p2, you should know how to draw the electrons by now, okay? 2 electrons here and 2 electrons here, okay? Now, this is what we call as the normal state, okay? This is the normal state, okay? And under normal state, okay, the electron exists in this way, okay? Now, if I want to form bond, okay, like for example, carbon wants to form bond with 4 atoms of hydrogen, okay, CH4. So what happens is carbon must prepare itself, okay, to receive 4 electrons from hydrogen, okay, 4 electrons from 4 atoms of hydrogen. But if you look over here, they cannot, they are not ready to receive, okay, they are not ready to receive. It's like getting married, okay, but you don't have any house to stay, okay. So you need to first prepare the house or at least room for you to stay. So what you need to do, okay, you are going to change it into excited state, okay? When people get married, they become very excited. They start to actually buy all the attire and everything, okay? And then try to buy everything to get settled down and so on. Under excited state, you are preparing, okay, to prepare to receive the electron. So how, okay? The electron over here, okay, they will go to this side, okay? I hope you can see this, okay? This electron, they will come over here, okay? So this is going to be the excited state. And you can see that the excited state of carbon is able to receive the electrons now, okay? They are ready to receive the electrons from 4 atoms of hydrogen. So where this electron will go, okay? If I just put it over here in this color, the electron will come here. In order for that to happen, okay, we are talking about total of 4 orbitals. Orbital 1, orbital 2, orbital 3, orbital number 4. There are 4 orbitals involved over here. So what is this orbital? This is going to be S, okay? This is p orbital, p orbital, p orbital. So they are going to mix, okay? The mixing of this orbital is what we call as hybridization. So you need, okay, 1 s orbital, you need 3 p orbitals. That's why, okay, each of these orbitals, after they mix, okay, they are going to become sp3 orbitals. So each of them, okay, are called sp3 orbitals. And it means sp3 has how many orbitals? They have total of, okay, 4 orbitals. Okay, so you need to know about this. So sp3. So if you're looking into this sp2 hybridization, what does it mean? It means you have one s, okay, with 2p, okay, not the entire thing. So it means it has sp2 means there are total how many orbitals? There are 3 orbitals that are involved. Okay, so please take note of this. Okay, so sp3 hybridization. So when I have bonds, okay, with H, I can say that, okay, the moment carbon has 4 bonds, it means they are going to have utilized 4 orbitals. So therefore, they are going to be sp3 hybridized. Okay, so that is sp3 hybridization. So let's look into sp2, for example. Okay, sp2 is going to be whenever you have like carbon double bond carbon and you have hydrogen and hydrogen like this. Okay, and of course you have another one here. But since we are talking about only one carbon, okay, this side, okay, we want to know what is the hybridization. Quite simple. See how many bonds that can be formed. Okay, 1 bond, 2 bond. Ignore one of the bond. That is going to be carbon and carbon. Okay, ignore the another line. So there are total 3 bonds that is being formed over here. Okay, for the electrons. So what you need is similar. Okay, if I erase, no need to erase. I'll just write down here. Carbon. Okay, let's say carbon 6. Okay, 1s2, 2s2, 2p2. Okay, they are under normal state. They are not ready. Okay, they are not ready, but now they want to get ready. So when they get ready, the same. Okay, they will get ready. You will have 1 electrons. Okay, they will go to come over here. Okay, something similar like what happened just now under the exciter state. So, but now I just need total of 1, 2, 3. Okay, I just need to receive, okay, only from 3. Okay, hold on. Okay, now you just need to receive 3. So I'll just put 1, 2, 3. So if it is 3, okay, you will use, okay, maybe here, and here. So how many we need to use is 1s, another 2p. So that's why each of them are going to be known as sp2. So what happened to here? Okay, what happened to this? The one that is not hybridized. Okay, for the one that is not hybridized. Okay, I think yeah, my internet is a bit slow. Okay, but you can see now. Okay, what happened to this electron that is not hybridized? The one that I circled over here. Okay, this one, okay, they will still form bond, okay, but the way that they form bond is going to be different, okay, which is going to be, will contribute to this, which is going to be the pi bond, okay, which is going to be the sideways overlap, okay, the sideways overlap. Okay, I do not know whether you guys can still see my screen. Okay, let me share the screen again. Yeah, hold on, guys. Okay. Hold on. Something's wrong. 2 minutes, yeah, guys. Okay. So as I was telling, okay, while this one is I try to fix. Okay, hopefully it can work. Okay, so I was telling about this. Okay, what is happening over here is, okay, the one that is going to be hybridized is going to be sp2, but the one that is not going to be hybridized, okay, they will form the pi bonding. Okay, so I hope you know what is sigma bonding and what is pi bonding. Okay, sigma bonding is going to be whenever you have any orbital, so you have heads-on overlap. okay, then it's going to form sigma bonding. Okay, pi bonding is going to be whenever you have sideways overlap. Okay, then you will have the pi bond. Okay, so what happens over here is this will form the pi sigma bond, one sigma bond, and one of it, okay, that will form the double bond is going to be known as pi bond. Okay, so if let's say this one is a bit too complicated, Mr. Gopi, I don't understand anything that you're talking about. Okay, I have an in-depth explanation, okay, of this part, okay, where I taught the students, okay, and you can go through, okay, there are 2 videos, okay, you can go through about this hybridization. Okay, but if let's say we go into this checkpoint, okay, let's say we want to check how many sigma bonds and pi bonds exist in a molecule of butanoic acid. So how many sigma bonds and pi bonds, okay, that they exist in over here? So first of all, you need to draw the displayed formula. So 4 carbon, and then this is going to be, you will have something like this. Okay, all these are going to be hydrogen. So you need to check, okay, you need to check all the single bonds, okay, are going to be the sigma bonds, and all the other double bond and so on, okay, one of it will be sigma, another one is going to be pi bond. So if I want to simply count over here how many sigma bond, okay, quite simple, okay, just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, one of it, so 11, 12, 13. So you have 13 sigma. How many pi bond that exists over here? This is going to be the pi bond. So there is going to be 1 pi bond. Okay. Now, too simple. Okay. Very easy. So let's say we try about something else. Okay. Maybe if we have this example. If I ask you how many sigma bond and how many pi bonds are there, you use the same thing. Okay, we have all the single bonds, okay, are going to be counted as 1 sigma bond. So this is 1 of it. So it's going to be 2. This is going to be 3. And the remaining 2 over here, this is 1 pi and another pi. So it means if I ask you how many sigma bonds, there are 3 sigma bonds and there are going to be 2 pi bonds in this particular molecule. Okay, so please remember this, okay, how to identify sigma bonds and pi bonds. And in order to understand this better, you need to learn more on your hybridization. Okay, now let's move on to this isomerism. Now, isomerism is going to be divided into 2, structural and stereoisomerism. Structural isomerism, we have 3, position, functional group, and chain isomer. Stereoisomer, we have cis and trans, and optical isomerism. So let's actually go on and find out what is going to be structural isomerism. So if you look at structural isomerism, as usual, you have the definition over there. They have the same molecular formula, but different structural formula. Okay, for example, okay, if you have your notes, okay, there is an error over there. So I want to show you position isomer, okay, for structural isomerism. Okay, for 1,2-dibromopropane and 2,2-dibromopropane. So how do I draw? Okay, propane, 3 carbon, 1, 2, carbon number 1, carbon number 2. So Br. The rest, I hope you know, okay, just put the hydrogen. I'm not going to draw everything. And here, when you have this 2,2-dibromopropane, this is 1, this is 2. So carbon number 2, you have Br and you have Br. Now, what you have over here is you can see the position of the Br is going to be at different place. When you have different place or different placing or different position, this is going to be known as position isomerism, which is counted under structural isomerism. So why they're counted as structural isomerism? If you just write down the molecular formula for this, just now I told you what is molecular formula, you can count 1, 2, 3, C3. How many hydrogen? 1, 2, 3, 4, 5, 6. H6, Br2. The same thing, if you do the same thing here, okay, you will notice that C3, H6, Br2. You can see that they have the same molecular formula, but different structure, okay? And another example of position isomer that you can see is like whenever you have like double bond, okay? Whenever you have double bond, okay, if let's say this is going to be one, put one in, okay, you can have the double bond moving to position number 2. You can see the movement of this double bond to here. This is also going to be counted as your position isomerism. Okay, so this one, please go through. Yeah, the next type of isomerism, still under structural isomerism, is going to be known as functional group isomerism. This one I can just show you related to carbonyl compound, propanal and propanon. Propanal, okay, this is going to be propanal. Propanon, 3 carbon, okay, this one. So if I just simply find out what is going to be the molecular formula of this, okay, the molecular formula is C3. How many hydrogen? There are 5 hydrogen here and 1 more hydrogen. So it's going to be 6 and 1 O. So if you look at here, 3 carbon, 1, 2, 3, 4, 5, 6, H6O. So you can see that they have the same molecular formula. Okay, but they are going to have different structural formula. Okay, you can see the structure itself, and the important part over here, functional group. Okay, what is functional group? This one is going to be aldehyde, and this one is going to be ketone. It's a total different in terms of functional group. They have different chemical reactions. So this is one of the example what we call as structural isomerism, which is under functional group isomerism. Now, next is going to be chain isomerism. Very interesting as well. Chain isomer, I like to actually call it like if you have a person, okay, and you become violent, you want to actually go and break that person's hand, or you want to cut the person's hand, okay? You cut the person's hand, don't go and attach the hand back to its original place. Or you don't go and attach the hand at the any part of the end, like for example, maybe this part. Don't go and put another hand over there. Okay, you cut the hand and put it over there. So what you need to do is, okay, I think the best way that I will suggest, try to attach that hand that you cut, okay, to maybe somewhere, maybe on top of the head or something like that, somewhere in the middle. Okay, somewhere in the middle. So like, for example, if I have butane, for example, okay, 4 carbon, if you have chain isomerism means, imagine this part is going to be your hand. I cut, okay? When you cut, you have this becoming CH3. So what happens? You are left with 3. And I told you, if you cut the person's hand, go and attach somewhere in the middle. So you put the CH3 here, okay? This is what we call as chain isomerism. Do not go and put the CH3 back to here or here. Okay, it doesn't work. Okay, you need to make sure you put somewhere in the middle. Okay, that is chain isomerism. Okay, I've explained about that. Okay, now let's look into the checkpoint. Okay, draw and name all the structural isomers for C4H8. Okay, so C4, okay, I'm not going to draw the let's say the full displayed formula or something like that. I'm just going to show you, okay, C4, okay, H8. This one follows CN, H2N. You should know this is going to be alkene. It involves double bond, okay? So let's say I put the double bond here at position number 1. First thing that you need to remember under structural isomerism, I taught you about this position, okay? You change the position. Same, you put over here. First, done. Position is done. Can I put the double bond here? Can, but it's still going to be the same. So no need. Okay, no need. So that's the first part. Done, settle. Now, second part is you always think about breaking the person's hand. Now, okay, break the person's hand, you break. Okay, you break, you will have 3 carbons. So put the double bond over here. Always put them in the middle. You break and you put the CH3 in the middle. Done. Okay. You cannot break over here. Okay. If even you break over here, you are still going to get the same thing. So cannot. So you can see 1, 2, 3. But the answer is 4. Now, always remember one more. Okay. For functional group, okay, always remember if you have CnH2n, there will be possibilities of having cyclic compound. So it means you can also have carbon in terms of this. So I have hydrogen, hydrogen, if you count, they are still going to give you C4, okay, H8. Okay, so how to name? Okay, this one I'm not going to write it down. You see, boot 1 in, boot 2 in. Okay, position number 1, position number 2. How to name this? This is going to be prop. Okay, 1 in. So if this is 1, carbon number 1, carbon number 2, so 2 methyl. Okay, if you are still not sure about naming, okay, just go and ask your teacher, or you can refer to the video that I shared over there. Yeah. So this is cyclobutane. Okay, this is cyclobutane. So please go through that. Okay, so what I want you to remember is going to be there is going to be a cyclic compound. Okay, now all the structural isomerism is done. Okay, I hope you remember chain, functional, and position. Okay, now we go into stereoisomerism. Okay, for cis and trans. So what is stereoisomer? They have the same molecular formula, same structural formula, but different arrangement in space. The way they are going to occupy space is going to be different. Okay, it means we are looking into 3D structure. Okay, so cis and trans. Okay, that is going to be the first example. Cis and trans will happen for any carbon double bond carbon. Okay, so whenever you have carbon double bond carbon, you can have cis and trans. Okay, but okay, you need to remember one important thing about cis and trans. Cis and trans can only exist if the carbon attached to the double bond is attached to 2 different groups. If I put A, B, it must be A, B, it must be different. If you have a situation where you have A and A, the carbon attached to the double bond is going to have the same 2 groups. It cannot be counted as cis and trans. So always remember, okay, it must be different. Okay, so it can be like this, or it can be also like this. And why you have cis and trans? Because there's no free rotation around carbon double bond carbon. Okay, it means that you cannot rotate. This thing cannot rotate. So it means that impossible to say that this can be changed into this. It means they are unique. Okay, they are unique. And there is another possibility. Is this considered as cis and trans, even though that they are not in your syllabus? Okay, please remember, since that they have 2 different groups, they are considered having cis and trans. Okay, this one just put it as alphabet C, yeah, not the same. Okay, so they are considered having cis and trans. Okay, now, for example, now if I put, okay, which one is cis, which one is trans? Okay, that is also important. You need to know which one is cis, which one is trans. Okay, if they are side by side, okay, if they are like this, okay, side by side, something like sisters, okay, so you call them as cis. Okay, if they are going to be opposite, okay, so like something like this, trans. Okay, if you have B and B, trans. Okay, so side by side cis, opposite is going to be trans. So example, okay, you have dibromo, ethene, and so on. Okay, you can see here. So if I have ethene, okay, 1, 2, so Br, okay, Br, okay. So if I have hydrogen and hydrogen, you can see that whether they have cis and trans, you can see over here itself, okay, the carbon is attached to 2 different groups over here, 2 different groups over here. So you can actually have cis, okay, what is cis? Side by side, this is already cis, okay, Br and Br, side by side. If you arrange them in this way, Br over here, Br over here, hydrogen over here, this is going to be trans. Okay, so this one done. Okay, I will move on. Now, another type of stereoisomerism that you need to know is going to be your optical isomerism. Yeah, one atom, okay, which is going to be known as chiral center, is going to be bonded to 4 different groups of atom. Okay, and when we form the image, okay, the images cannot be superimposed. Something like your hand. Okay, your left hand and right hand, even though they are looking same, Okay, they are mirror image to each other, but if you try to put them together, they cannot superimpose. They are not the same. Okay, you can see here, they are not the same. So this is stereoisomerism. The important thing is you must have a chiral center, one carbon attached to different groups. Okay, let's say, for example, I just use numbers 1. Okay, group number 1. And this one, group number 2. We draw like this. Okay, group number 3. Okay, there is a way to draw. Okay, and then this one is going to be dotted line, number 4. Okay, so all these 4 groups, okay, must be different. Okay, and when I actually draw the mirror image, okay, I will just draw like this. Okay, 1. So this one is going to be 4. Okay, this one I'm going to have 3, and this is going to be 2. So something like that. Okay, and differ in their effect towards polarized light. You can actually just go and find out about this. Okay, and I will just go to this checkpoint number 4. Okay, draw the cis and trans isomer for C4H8. Now, cis and trans C4H8. I have done C4H8 just now. Okay, so let's look at it. Where is it? Yeah. This one, C4H8. If you go and look over here, you need to find out which one can have cis and trans. Okay, so in order to get cis and trans, I told you how to identify the carbon attached to the double bond must have 2 different groups. This is hydrogen and hydrogen, automatically cannot. Okay, this is going to be hydrogen. This is CH3. Okay, this is going to be hydrogen, CH3. This is okay. Can exhibit cis and trans. Don't have double bond, no need to worry. Hydrogen and hydrogen don't have cis and trans because they have the same group attached to the carbon over there. So I'm just going to focus over here, okay, which is going to be my but2 in. So if I bring my but2 in here, okay, this is the one that will give you your cis and trans. Okay, so how do I draw? Okay, you put this one CH3, this one H, you put H, you put CH3. Okay, so if you want to show them better, okay, you draw like this, C, H, CH3, and then H, CH3, side by side. Okay, CH3 and CH3 side by side. This is cis. If you have C double bond C, CH3 here, CH3 here, they are going to be opposite. So this is going to be trans. Okay, done. Yeah. Now, additional references. Okay. Now, this one, of course, we are going very fast. But if you look at this, okay, I have given so many additional references that you can go through. Okay, the 18 videos, 9 videos, and so on. Okay, and if you, yeah, you can, there is a playlist over there. You can just go through those. Okay, but now I will enter hydrocarbons. Okay, now, so I will try to increase the speed. Yeah, now maybe we won't be able to cover everything, but I'll try to cover everything. Okay, so that we are still on track. Yeah, now hydrocarbon, we have 2 types. Okay, alkane and alkene. Okay, and then we are going to learn about the reactions of alkane. Alkane will undergo combustion. Okay, complete combustion, incomplete combustion. Complete combustion gives you carbon dioxide and water. Incomplete combustion gives you carbon monoxide and water. Okay, but what is important for alkane? You need to know about free radical substitution. Okay, so what is free radical substitution? Free radical substitution is going to be a slow reaction, okay, that will happen only specific for alkane. Okay, and it will happen under the presence of UV light, okay, or the presence of sunlight. Okay, and what is important over here, you need to know the mechanism of the reaction. Okay, so if we look into the mechanism of this reaction, let's say I want to draw ethane. Okay, you have ethane, and I want to react with bromine over here. Okay, so ethane with bromine. So I want to show, yeah. So here I'm going to use CH3, CH3. Okay, structural formula, easier. Okay, easier to look. So if I have this, okay, what you need to do, the first one is going to be your initiation step. So what will happen under initiation step? You are going to have Br2, okay, you are going to have what we call as homolytic fission, okay, they are going to have the breaking, okay, of the electron, where you are going to have Br dot and Br dot over there, okay, this is going to be free radicals. Okay, so homolytic fission. Okay, you can go and find out more about this. So you'll have this. Okay, free radical is being formed, and this thing will only happen with the presence of UV light, and it's quite slow. Yeah. Now the next step is going to be your propagation step. Your propagation step. Okay, always remember neutral molecule with free radical. It's always like that. Neutral free radical, neutral free radical, neutral free radical. So what happened? You need to have a neutral molecule. This is the neutral molecule, CH3, CH3. You react with free radical. What happened? One of the H from here, okay, the H over here will go out, okay, and you will join with the free radical Br. You are going to get CH3, CH2. There's a homolytic fission, so there is going to be a dot over there, okay, and this is going to give you HBr. Next step, you are going to have a free radical. Okay, this is going to be the free radical. You are not going to react with another free radical. It must be free radical with neutral. The neutral molecule is Br2. Okay, always remember this. And that is going to give you CH3, CH2, Br left with Br free radical. Okay, this one is very important. Learn how to write the propagation step. I will only write for one, okay? And then if they want to continue, yeah, you can continue. But the last step is going to be known as termination step, okay? The termination is going to be you have free radical with free radical, and they will join to give you a neutral molecule to stop the reaction, yeah? So this is going to be the reactions, okay, or the steps involved, okay, for free radical substitution, yeah? Now, let's move on to this reaction of alkene. Now, for the reactions of alkene, okay, just now combustion. For alkane, combustion, and then free radical substitution. Okay, but now you are going to have combustion, electrophilic addition, oxidation, and addition polymerization. Yeah. Now, for combustion, okay, I'm not going to discuss because it's the same thing. Okay, it will give you complete combustion and it will also give you incomplete combustion. Yeah. Can this William? Can. Is this the one? Okay. Now, as let's say William is looking over there, you can actually just look at, okay, if you have this reaction, okay, there are total of, okay, four reaction: combustion, electrophilic addition, oxidation, addition, polymerization. But the main part is going to be an electrophilic addition. Anything that has carbon double bond carbon, they will undergo electrophilic addition. Okay, and this electrophilic addition, there are 4 in our syllabus. You need to know that carbon double bond carbon, they can react with hydrogen. They can react with water, they can react with hydrogen halide, they will react with halogen. And the conditions, very important. Hydrogen, what are the conditions? Nickel catalyst, 140 degrees Celsius. What will happen? Okay, when you add hydrogen, okay, the hydrogen will come here, hydrogen will come here, the double bond is broken. So if I just write down, okay, what will happen? You will have something like this, okay, plus H2. You will have everything is going to become saturated bond. Okay, alkene will change into alkane. How about steam? Okay, when you have concentrated phosphoric acid, 330 degrees Celsius, 6 megapascal. Okay, so if I have carbon double bond carbon, when I react with OH, what will happen? The H, okay, the double bond is broken. H will come here, OH will come here. Okay, and you will get alcohol. Okay, you will get alcohol. And then hydrogen halides. Okay, I think the part that you need to remember over here for hydrogen halide is this concept. Okay, rich becomes richer concept. What is that concept? Okay, actually you need to go through this in detail. Okay, but I'll just simplify it a little bit for you guys. Okay, if you have, like, for example, HCl, and I want to react with carbon double bond carbon. Okay, and then I have all this hydrogen over there. Okay, so here, okay, you will have 2 situations. What are the situations? The hydrogen, okay, they will come, the double bond is going to be broken. So the hydrogen can come maybe here or here. Okay, break the double bond first. and then the Cl maybe vice versa. So you might get carbon, carbon, okay, hydrogen, hydrogen. Okay, if I just rewrite this again, okay, so you might have a situation where hydrogen come here, Cl come here, or you can have hydrogen coming here, Cl will come over here. Okay, you will have a mixture of products, but one of the product is going to be major product. Why? You can actually just look into this concept. Rich becomes richer. It means hydrogen will go to the carbon that has the most hydrogen. If you look at this carbon, okay, it has only one hydrogen attached to it. If you look at this carbon, it has two hydrogen attached to it. So hydrogen will go to the carbon that has most hydrogen. It means the hydrogen will come here. Okay, so it means the major product, okay, is going to be, instead of forming this, you are going to get H, hydrogen will come here. You will have HCl, CH3. You will have something like this. Okay, so this one is quite important, and all this will happen at room temperature and room temperature. Okay, but what is the most important thing? The most important thing is to write down the mechanism. Okay, this mechanism is quite important. So if I have carbon double bond carbon and I have Br2, okay, at room temperature, what will happen? Yeah. So how do I draw? Okay, using curly arrow diagram. You need to know when they come nearer, Br and Br, when they come nearer, there is a lot of electrons over here. What will happen? This electron will push the electrons over here to go to the other side, making this partially negative, making this partially positive. Okay. And what is going to happen next? Okay. The curly arrow must show the movement of electron. Okay. Electrons are here. And you are going to have, okay, a lot of electrons to positive. So the arrow, okay, when you draw, okay, it must be movement of electrons. A lot of electrons here, movement of electrons over here. The arrow will be something like this. And what will happen? Now you will have homolytic fission. Okay, you will have a situation where you have the carbon-carbon. Br will be formed over here. Okay, the rest, okay, you will have something like this, and then you will have a positive over there. And next, okay, is going to be this Br. Okay, let me see again. Sorry, guys. Okay, let me share the screen again. Hold on. So what will happen over here is the Br, okay, that went over here, the negative over here, okay, they are going to have, okay, a situation where the electrons, they will come over here. So this one, sorry, just now, they will undergo heterolytic fission. It's going to be different compared to the fission that happened for your free radical substitution, heterolytic fission, okay. So you will have like this, when they join together, you are going to have, okay, the Br coming over here. So what will happen? How do I draw, okay, for HBr then? Then it's same, okay, you have carbon double bond carbon, okay, and you have HBr, okay, and this one is more electronegative, so electron will go there, delta negative, delta positive, okay, the electron will move over here, okay, the hydrogen, okay, in this case can go to any carbon, okay. So let's say the double bond is broken, the hydrogen will come over here, okay, and then I will have this positive, okay. So I have Br, okay, being negative now, it will come over here. Do remember, the arrow is movement of electrons. And when they come over there, you are going to have this over here, okay, the Br and H over there, yeah. So this is going to be what is going to happen for the mechanism. Now, I don't think so we will have enough time to cover oxidation. Okay, we will go through that next lecture. Okay, so we leave oxidation now. Now, for addition polymerization. Okay, so for addition polymerization, okay, what we need to learn is going to be we need to know, okay, that your Sorry, guys. I think my internet is not stable. Yeah. Now, the addition polymerization, what you need to know is, okay, let's say, for example, you have this alkene. And this alkene, they can form polymer. Okay, so polyethane, for example, ethene to become polyethane. So how do I form that? Okay, so you need to know double bond carbon. Okay, and then when what will happen is going to be, if you, let's say, for example, you have hydrogen, hydrogen like this. Okay, you just need to bring this over here, hydrogen at the top, hydrogen over here, and then you just extend over here and put N, something like that. And what is important for this is going to be, you need to know about the problems, okay, for addition polymer. Okay, the problems is, okay, you are going to have a saturated bond over there. There is no double bond. And this bond, okay, once you do that, they are going to become unreactive. Okay, they are unreactive. They do not react. So it's going to be difficult to be biodegradable, difficult to dispose. Okay, they are going to cause a lot of pollution. Yeah. So you can see some of the questions that I put over here. Like, for example, which statement about polyalkane are correct? They do not react, okay, with Br2 in the dark. Yeah. Okay. They don't react. Okay. Because, okay, if they want to react with Br2, then have to be with UV light, because all of them are going to be saturated. Okay. You can see saturated carbon single bond. And then you can see the disposal can produce harmful products. Yes, okay, if it is when you combust, okay, they can give you harmful products. And then they do not readily biodegrade, correct? Okay, so the answer is going to be 1, 2, 3. And other examples you can see here, okay, you can go through all this, okay. They ask you, okay, how many number of isomers and how many pi electrons are there. Okay, the CH3 can come over here, can come over here, and so on. Okay, so there are 5 combinations. Okay, there are 5 combinations, and then number of electrons. Okay, the pi electrons. Do remember just now when I put the pi bonding. Okay, even though they overlap sideways. Okay, each pi bonding. Okay, they have 2 electrons. Okay, so 2 electrons here, and you have 2 electrons here. So total, they're supposed to have 4 electrons over there. So 5 and 4. Okay. If you are not sure, okay, just ask with your teacher. I think they can actually help you to go through all these questions over here. Okay. Like, for example, if you want to find out which compound has molecular formula, okay, you need to count. Okay. This is going to be skeletal formula. So you need to count how many carbons are there, how many hydrogens are there, and then you just need to find out. Okay. So like, for example, I just show you example. Let's say this is A. So when I calculate, okay, each carbon 4 bonds, okay, 4 bonds, and then each carbon 4 bonds, okay, another 3, okay, this is another 1 more, okay, 4 bonds, 4 bonds, okay, that one is complete. So if I count how many hydrogens are there, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, this is going to be 10. Okay, so you count. Okay, so this one is going to be C6H10O. Okay, then we select as A. Okay, something like that. Okay, next is going to be which one is chiral. Okay, so in order to find out something is chiral or not, okay, we need to look at the carbon that is bonded to 4 different groups. Same groups, 3 cannot. CH3 and CH3 cannot. Okay, 2H cannot, 2H cannot, not chiral center. Okay, so you eliminate, okay, each of them. So if you look at this answer C, okay, you don't have, okay, but if you look over here, this CH3 and CH3, this one also cannot. But if you look at here, okay, this is one group, this is another group, this is another group, this is a chiral center. Okay, so this one can form chiral center. Okay, then you can actually select them as the answer. Okay, something like that. Okay, and please go through all these questions. Okay, I don't think so we can finish this, but I will go through some of these questions in our next lecture. Yeah, but the answers are given. Okay, the answers are given. Okay, but what I want you to do over here is, okay, the last part as usual. Okay, I know the time is almost up, okay, but okay, I will share to you, okay, the quizzes, very simple questions, okay, so we can just go and do this. Okay, so I'll share to you. Very simple 7 questions about our concept today. Yeah. Okay, please join. Okay, for those who are joining, you can still join. Okay, I will just start. Okay. Okay, while you're doing this also, okay, please listen to my announcement. Okay, you can continue this. Okay, later if you couldn't do this well as well, okay, I will give you the link as usual. Okay, you can try again later. Okay, I will open it until 8 o'clock tomorrow. There is another link that I sent in the chat. Okay, which is related to the Padlet link about reflection. Okay. So there's a lot of things that I wanted to cover with you today, okay, but I think it took time because we even started late. We will cover, okay, certain parts. If you have questions, okay, I will try to answer maybe 15 minutes, okay, for next lesson, okay, on Thursday. You can ask, and then I will try to address all those questions with you, yeah. So this one you can continue, okay. If you have class, okay, you can leave the meeting now. Okay, so you can continue these quizzes, okay, if you still doing, okay, but hopefully I think you can answer most of those questions. They are very easy questions, okay. Like for example, what is the condition? Yeah, you need to memorize, yeah. So condition is supposed to be nickel catalyst, okay, at 140 degrees. And then here, what are the condition? Yeah, condition. I think the condition, because we went very fast, okay, maybe you do not know, okay, you missed that part. It's supposed to be concentrated phosphoric acid, 330 and 6 megapascal. Okay, and then a diol, this one is okay, because we didn't cover. Yeah, so next lesson, we will try to cover the oxidation as well. Yeah, so that's all for today. Okay. I need your reflection. Okay, the lesson today, okay, didn't go as planned. So if you want to write down, yeah, please write down as well. Yeah, so we can plan in future. Yeah, so please make sure whatever things that we learned today, okay, they are available, okay, in form of video. You can go through them as well. Yeah, thank you guys. See you. Bye.
Thank you, Mr. Bye, Mr.
Yeah, see you.
Bye, sir.
See you.